Hello class! Today we're going to do a free body diagram example with a mass on a table connected to a rope over a pulley, and on the other end is a small little mass. Now we're going to try to figure out what the acceleration is of the whole system, what tension is, and the normal force. Now the first step is to draw all the vectors on the diagram. Okay, so all the force vectors. We'll do the easiest one first. We'll do weight. So M1G is a weight for the big box, and M2G is a weight of the little box. Right. Here on the table, Newton's third law states a reaction is a reaction. Here, table is resting on, box resting on the table, so therefore we have a normal force pointing up. Now since this is on a string or a rope, there is tension between the two boxes. We have T1 and we have T2. Alright, now our second step is to redraw this diagram as a straight line. We're going to draw a big box, string, little box. Label this M1, M2. Here, weight's pointing down, big 1G, normal force up. For this one, gravity weight is pointing this way according to that diagram. Then we have our tension, T1 and T2. Our next step is to write sum of the forces equals. Now we decide which direction we're going to apply it to and what we're trying to solve. We're trying to solve for the acceleration. Right. In this case, acceleration is going in this direction. Now we'll draw a coordinate system so that we can define that direction as x, and we'll define up as y. That's the direction of ax. So we're going to do some of the forces in the x direction. Now since this system is moving, we'll assume, we're going to label this m times ax. Now we need to add all the forces in the x direction. So we have T1 minus T2 plus M2G equals, now for the acceleration, right, our system is this right here. And we need to include all the masses in our system, which is M1 plus M2 times the acceleration in the x direction. T1 and T2 equal each other, so they cancel out. Now we can solve for A. We rearrange the equation. We get M2 times G all over M1 plus M2 for the acceleration. Alright, now our next task is to solve for the tension. Now we can't use this big system because when we do, tension cancels out. We don't want that. We want to solve for one of the tensions. So to do that, we're going to break up our system right down the middle in half. And we're going to pick a side that has the least amount of arrows because I think it's easier. Right, so we're going to pick this side because there's the least amount of arrows along the x direction where tension is pointing. Okay, so we got to go back, do sum of the forces. This is moving equals MA. We're doing the x direction. All our forces is just a positive T1. All our masses in that system is just big M1 times AX. Right, and we just already solved for acceleration from the previous problem. And there you have it. Now, for the normal force is over here. That's pointing in the y direction. So sum of the forces in the y. Now, we need to decide, is this object moving in the y direction? Is this object moving up and down? Is it floating in the air? Is it going through the table? No. Since there is no movement, that means that it equals 0. So therefore we add all our forces. We have positive N minus M1G equals 0. So now we can solve for the normal force, where N equals M1 times G. There you go, and there you have it. Solve 3 variables. They're using the help of a free body diagram.